Quiet, quiet, please. Okay, we got a lesson to go through. When we're done with this, I'll give you back your quiz that we did the last class. Okay, so these dates are wrong, but losing the 3 days that we did, we're still in good shape. I mean, we had a few days to play with, and this didn't really affect us getting things done that I wanted to get done this semester. So we're still in good shape. I would expect that we're going to do this lesson will go over 2 days, and then we review on Monday and then test on Tuesday. And that still leaves us Wednesday, no, actually not Monday, right, because we don't have school Monday. But we'll review on Tuesday, test on Wednesday, and they still have Thursday, Friday, Monday, Tuesday. Actually, no, Tuesday is your exam day, right? That's the way it works. Tuesday the 24th is the exam day for 2AB. Okay, so now we're going to be we've been doing inequalities in this unit so far. They were always one variable inequalities, the kind of things that you could graph on a number line, okay? Now we're doing two variable inequalities, right? And how do we graph things with two variables? Not on a number line. We use the XY axis to graph them. So that's what's different about this from what we've already done. Okay, so linear inequalities in two variables, right? How do you know that it's linear? Because the variables are raised to the first power, right? It's an inequality because it's using one of these four symbols. And the graph is going to consist of a line on the coordinate plane and then shading on one side or the other. Okay. So, I think I've got my pen in the right place. So I'm going to compare the equation 2x minus 3y equals 6. What form of a line is that? What form of the equation of a line is that called? It's standard form, right? And remember, you could graph standard form with the intercepts. You could solve for y, but you could also do it with the intercepts. So just to check my graph so far, I graphed this line by finding the x-intercept. I covered up the y and solved for x, and I got 3. And then I covered up the x, and I solved for y, and I got -2, right? And then I drew a line. Okay. Now, when I graph the inequality, the first thing I've got to graph is the line, right? And the line is what you would get if you just had an equal sign, right? So there's my line. Okay, next. I know that, in fact, the solutions aren't just going to be all the points on this line. It's going to be those points plus all the points on one side of the line. Okay, so there's two ways to do this, right? And the first way is we take a test point and we plug it in to see whether it satisfies that inequality. Now, usually if 0, 0 is not on the line itself, that's a pretty good point to test. Like, what would I get if I plugged in 0, 0 here? 0 is less than or equal to 6. Is that true? It is. That means that it must be all the points on that side of the line that are part of the solution. So I would have to show the shading, and I'm just going to show my shading like this, right? The shading all goes on that side of the line. Right? That's what the graph of a two-variable inequality looks like. It's the line, and it's the shading on one side of the line. Okay, now the difference between this one, which is the same one we just graphed on the last page, and the one on the left is, right, this one is not or equal to, right? So how does that change the graph? That means we're going to make the line a dashed line, right? When we were doing one variable inequalities, what did we do when we had a less than or a greater than? We used open circle to say, that's not part of the solution. When we want to say that that line is not part of the solution, then we make it a dashed line. Right? It's still in exactly the same place. But that's the difference, right? Less than, dashed line. Or equal to, solid line. So shading. Okay, so these are the steps to graph a linear inequality in two variables, right? The first thing we got to figure out, where's the line going to be? So graph the line. Right? If it's a less than or a greater than, use a dashed line. If it's a less than or equal to or greater than or equal to, use a solid line. That's the first step. Second step, test a point. Right? Take a point that's not on the line and plug it into the inequality and see whether it leads to a true statement. If it does, shade that side of the line. Right? If it doesn't, shade the other side of the line. I believe we copied this one as extra credit homework after the last test. Right? Okay. Okay, so the first thing, okay, let's practice substituting a point and seeing whether it's part of the solution or not. Right? Which one of these ordered pairs is not part of the solution to x minus 3y is less than or equal to 6? Okay, so let's plug in, and it doesn't necessarily have to be 1. Let's check all 4 points. Is 0, 0 part of the solution? Okay, let's check. 0 minus 3 times 0 is less than or equal to 6. That tells you that 0 is less than or equal to 6, which is true, right? So you're going to say solution. Okay, try the next one. X, 6 minus 3 times negative 1 is less than or equal to 6. That'll be 6 plus 3 is less than or equal to 6. 9 is less than or equal to 6. False, right? So that's not a solution. Okay, test the next one. 10 minus 3 times 3 is less than or equal to 6. All right, that'll be 10 minus 9 is less than or equal to 6. Is that true? Yeah, in the end, you're right. But we'll test them all anyways as practice. Okay, so that is a solution. And the last one, negative 1 minus 3 times negative 2, positive 2, is less than or equal to 6. So negative 1 minus 6 is less than or equal to 6. Negative 7 is less than or equal to 6. That is true, right? So the only one that was not, the answer to this multiple choice question was B. Right? The only one when we plugged it in that was not, that was led to a false statement was actually this B, when we plugged in 6 and negative 1. So that is the answer. Okay, so test these 3 points on this equation, right? This is your U try. What did you say in the first one? Okay, the first one I plug in a 0 and a 0, I would get 0 is less than 8. Does that make it a solution? Yes. That's a yes. How about the second one? Let's see, negative 0 plus 2 times 4 is less than 8. That's telling me that 8 is less than 8. Is that a true statement? No, that's not a solution. How about the next one? Negative 3 plus 2 times 5 is less than 8. So that gives me 7 is less than 8, which tells us, yes, that's a solution. 7 is definitely less than 8, so that's a solution. Okay, so now we're going to do the whole thing, right? Graph the inequality. So in this case, what's the form of the line that I've given us here? I mean, that's slope-intercept, right? So we just do the, by all means, we should know how to graph this line pretty easily, right? What's the first point that I graph? The negative 3, the y-intercept, right? And then if a slope is 4, how's that telling me How to get to the next point on the line? Up 4, right 1, right? So that's like a 4 over a 1. So up 4, right 1. So my line's going to connect those 2 points. Okay, next, right? So we're going to graph the line y equals 4x minus 3. Okay, next. Is it solid or dashed? It's greater than, is it greater than a solid or a dashed line? It's dashed, right? Because it's not or equal to. Or equal to, solid line, kind of like the closed circle on a number line. So let me do this with a fancy tool here. Blue and something like that. Oh, I just said it. No, you're right, dashed. Okay, then test a point. Is 0, 0 a good point to test? Yeah, it's not on the line, so let's take 0, 0, right, and test it. That would make it 0 is greater than 4 times 0 minus 3. So 0 is greater than negative 3. Is that true? Okay, so what does that tell you? We just tested that point and we got a true statement. So we shade on that side, right? So shade on this side. Okay, and so that's the graph of the two variable inequality. It's a line, solid or dashed, and shading. Yeah. The greater sign is here. I mean, it's in the original. Okay. Right, so that's what the graph looks like. Yeah, Connor. You could use any point, just not a point that's on the line. So, take something that's clearly not on the line. And if you're not sure, go farther away. Okay, how about this one? So we're going to try to graph the line x plus 2y equals 0. Could we do this one by finding the intercepts? I mean, if you did, right, if you covered up the y in solve for x, what would you get as the x-intercept? 0. That's the origin, which means that actually the x and the y-intercept are the same point. And how many points do we need to graph the line? 2. So that's not going to work. How about we solve for y? Right? Let's solve it like a slope-intercept equation. Right? How do I solve this equation for y? Subtract x. 2y equals negative x. So y equals negative 1/2 x. Okay, now graph that line. What's the y-intercept? No. What's the y-intercept? Remember, it's mx plus b, and you don't see a plus b, so it's 0. Right? What do you call that special kind of linear equation? It's a direct variation, right? Remember, all direct variations go through the origin. Okay, next. Okay, how do we use the slope of negative 1/2 to find another point on the line? Well, remember, if it's negative 1 over, you got to either do it like negative 1 over positive 2 or positive 1 over negative 2, right? If I do this one here, that means down and to the right. So down 1, right 2, there. And now, should I use a solid or a dashed line? Solid because it's or equal to. So let me use this solid. Okay. So something like about this. Okay, now we have to test a point. Can I use 0, 0? No, because it's actually on the line. So pick another point, something that's easy. 1, 1, okay? So let's take the point 1, 1, which would be right there. Okay, now we get 1 plus 2 times 1 is less than or equal to 0. 3 is less than or equal to 0. Is that true? 3 is less than or equal to 0? That's a false statement. What does that tell you about where the shading goes on this graph? It's got to go on the other side, not the side that had that point, because that point led to a false statement. Yeah, Lily. They're not going to ask you to do that. They might give you one like that's like, here's the graph with shading and line, and ask you which one of these inequalities led to that. But they can't ask you to actually shade it unless they've come up with some new tools I don't know about. Okay. So here's another way. Here's another way to do the thing, which is almost better than I think than doing a test point, which is before you graph it, make sure you solve for y. Okay, solve for y first. Then we're going to graph the line using slope-intercept rules, right? But if it's a greater than or equal to, then you shade above the line. If it's a less than or equal to, then we'll shade below the line. But we won't need to do a test point. Now, we end up having to solve for y in lots of other places in this class. So that's actually a skill we should get pretty good at. So, I mean, I find that we're better at that probably by the end of this course than we are at plotting the x and the y intercepts. But, I mean, you could do either way. It doesn't matter. They're both good ways. So let's take the same problem here, which we already solved this one, right? We said this was y is less than or equal to negative 1/2 x. And we graphed this point and this point, and we connected them with a line that looks something like that. And now, instead of doing a test point, according to these new rules, it says, if this is less than or equal to, you shade below the line, right? I don't need to do a test point. That's telling me which way to shade. So shade below. If it was a greater than or equal to, you shade above the line. Okay, so solve for y, graph the line, solid or dashed, shade above or below. That's the whole change. I think I've got one for you to do. So you try to do this one, probably in that way. Solve it for y first, graph that line, solid or dashed, shade above or below. Okay, here we go. So x plus 3y is greater than or equal to negative 1. You have to solve that for y. So subtract x. 3y greater than or equal to negative x minus 1. Divide by 3. That means that by 3, that by 3, that by 3. Everything by 3. Y is greater than or equal to, and I'm going to make this negative 1/3 x minus 1/3. Okay, so what's the first point to graph? The y-intercept is what? Negative 1/3, which means it goes about right there. Oops, that didn't work. About right there. And then the slope is negative 1/3. So how do I find another point? Down 1, which means you're like a little lower than negative 1, right 3, so it's about right there. So do I use a solid or a dashed line? Solid because it's or equal to. So here's my line drawer. So it's about like that. That is actually not great. That'll be good. And now, do I shade above or below? Right? It says greater than here, so that means go above the line. Okay. So that's graphing a two-variable inequality. John? What's that? Which they're both negative 1/3. This one or this one? Okay. So we start at negative 1/3. Do you see where that's negative 1/3 on the y-axis? In between 0 and negative 1. And so from that point, we should go down 1, right 3. That's using negative 1/3 as a slope. Down 1, right 3. Does that make it clear? Okay. Okay, So that is the lesson for today. And then we got a little bit more to add tomorrow. And that's the homework.